Hello everyone. In this lesson, we will talk about derivatives of transcendental functions. So what are transcendental functions? Transcendental functions involve trigonometric functions, sine, cos, tan, cotan, inverse of cosine and tan, tangent and cotangent, also secant and cosecant, and also derivative of logarithm of a function, derivative of natural logarithm of a function, also the derivative of function raised to a power. When we talk about derivative of transcendental functions, basic rule for derivatives still applies. So we've learned about chain rule, product rule, and quotient rule. So when it comes to applying all of this rule, we still have to take them into considerations, even though we work with the transcendental functions. Besides working with the basic rule for derivative, we also have to pay attention to the formulas that are given to us. So in the first lesson, I will concentrate on derivative of sine and cos. That means formula number 1, formula number 2. I also emphasize the product rule. I also emphasize the quotient rule as well. Okay, so if we are talking about derivative of a function, we are using the chain rule in this case. Okay, so you see it's always applied to all of these transcendental functions that we are working with. If you are working with derivative of sine, then the result for that would be cos. So derivative of sine of u, the solution would be cos of u, but then you have to multiply this result with the derivative of the argument of your function. So sine of a function. So find the derivative of that function u as the argument for your trigonometric function. So in this case, you see times du over dx. Excuse me. So if you find derivative of cos of a function, so the solution for that would be negative sine of u. Then you apply the chain rule. That means you multiply by derivative of u as a function of x. Don't forget, u is a function and u is the argument of your trigonometric function. So most of the formulas applies with the same patterns. However, you see the derivative of tan will be secant of u. So derivative of cotan will be negative cosecant square of u. So we have to use this formula sheet in order to work with finding derivative of a transcendental function. So we will get back to this from time to time. So let me get to our lesson today. So our lesson for this video will be finding derivative of sine, cosine, tangent, and cotangent. And I will emphasize the chain rule and the product rule. I may not have enough time to get into tangent and cotangent, but we will talk about derivative of these two transcendental functions in our next video. Okay, so let's get started with example 1. So for this particular example, before you start anything, I would like you to analyze your function a bit. So you have y equal to negative 5 times sine of a function, right? So you are going to realize that the u is x squared plus 3x in this case. So then you go to your formula sheet. You see the formula saying that derivative of sine is the cos of that exact function again, but then you just multiply by derivative of u as a function of x. Okay, so then what I will do is I will write down the formulas for everyone. So the formulas will be derivative of sine of u as a function of x is equal to cos of u, and then you multiply by du over dx. Okay, so we are using formula number 1 for this. So in this case, what you do is your u is in fact equal to x squared plus 3x. Okay, so then you are going to find derivative of u as a function of x. We've done this before, so this is very simple. Derivative of x squared is 2x, and derivative of 3x is just 3. So all you have to do is just substitute what you have into the formulas right here. Okay, so now you see y is equal to minus 5 times sine of your function u. And you already let u equal to x squared plus 3x, you find du over dx. So all you do now is just finding derivative of this function. So you immediately change this into negative 5 times sine of u. It means that negative 5 times cos of u, and then you multiply by du over dx. So in this case, dy over dx will be equal to negative 5 times cos of u, and you let u equal to this functions right here. Alright, so you will write it as x squared plus 3x, and this whole thing is going to multiply by du over dx, which is 2x plus 3. So in the end, you may want to simplify by writing your answer as negative 5 times 2x plus 3 multiplied by cos of x squared plus 3x. And that is the final result. Alright, okay. So all we have to do is just apply the formulas. Derivative of sine turn into cos of the exact function again, and you multiply by derivative of that argument. Okay, argument u in this case. So don't forget, in this case you just have sine. There isn't any exponent for sine. So if there is an exponent, you may have to consider using the power rule and apply the chain rule as well. Okay, so let's move on to our question number 2. Okay, so here we have derivative of a function cos. So I am going to write down that derivative of cos of u, right? Okay, so as a function of x, this one should be equal to negative sine of u, and then I multiply this by du over dx. Okay, so that means you are going to let u equal to square root of x. So that means x to the exponent a half. So when you have x to the exponent a half, you can go ahead and differentiate this. So du over dx is equal to a half times x. Take 1 away from a half, so I will have negative half. Okay, so your du is in terms of x is done. So let me simplify this by rewrite it as positive exponent. So this will give me 1 over 2 times x to the exponent a half. Okay, so just to remind everyone, this formula is here. A to the negative n will be 1 over a to the positive n. And in the end, I can write my du over dx as 1 over 2 times square root of x. Okay, so keep that in mind because we need to substitute it into these formulas, right? Okay, so then we have y equal to 4 times cos of u. Okay, so when you are finding derivative, that means dy over dx. Now we turn this 4 cos of u into the exact, like 4 sine of u as a negative. So it's negative 4 times sine of u, which is the square root of x. Okay, so that's the first thing. And then you multiply by du over dx. Okay, so times du over dx is 1 over 2 times square root of x. So how about we simplify our answer? So that and that cancel will give me negative 2. So I will have dy over dx equal to negative 2 over square root of x times sine square root of x, or you can write your answer like this: negative 2 sine argument square root of x, the whole thing, divided by square root of x. Alright, okay, so it's pretty simple. So this one, I think we done it on the side. It's always a good idea to define the u and then find your du over dx. Okay. Alright. So let's start with the next question. Okay. And in the next question, I would like everyone to make a comparison between these two. So I have y equal to sine of the function x raised to the exponent 3. But this one here, I have y equal to sine exponent 3 of x. I would like you to note the difference between these two. They are totally different. Okay, so the exponent 3 here is for my argument, but the exponent 3 here is for my function. Alright, so let's do one at a time. Then we will realize the difference between the two. So for this, u will be equal to x to the exponent 3. So then I will find du over dx, which is equal to 3x squared. Alright, okay. So what is the formulas for finding derivative of sine? So derivative of sine of u as a function of x will be equal to cos of u times du over dx. So this is what I have to apply. Okay, so then in the end my dy over dx will be equal to derivative of sine is cos, so I put cos of x to the exponent 3. Then I multiply this whole thing by 3x squared because I multiply by du over dx. So dy over dx equal to 3x squared times cos of x to the exponent 3 as a final result. Okay, so the basic formulas apply. So my argument is x to the exponent 3. So u equal to x to the exponent 3, du over dx equal to 3x squared. Then I just substitute what I need to substitute into these formulas. Alright, so but for this particular one, the exponent 3 is for the sine. Then you have to apply a function raised to a power. Okay, so we need to apply. I'm going to make a note here for everyone that apply derivative rule of function raised to a power. At the same time, we also have to apply the derivative of sine. Three things you need to do here. Okay. Okay, and plus you have to multiply by derivative of u as well. Okay. So in this case, it's just equal to u equal to x, so it's just equal to 1. Okay, so I make a note here. U is equal to x, so du over dx is just equal to 1. So in the end, how do I do this? So y equal to sine raised to the exponent 3 of x. Okay, so I must apply the chain rule, which is I will need to take 3. Here is the exponent. I multiply the coefficient at the front, which is 1. So I should have 3 times sine square of x. Okay, so that's the first thing you do. The second thing you have to do is you have to apply derivative of sine. So what is derivative of sine? Derivative of sine is cos. So I will write cos of x. Okay, derivative of sine is cos of x. Alright. And the last thing is derivative of f, which is 1. Okay, so let me make a note here. So this is a power rule. And this is derivative of sine. And then this one is the derivative of x. Okay, so when it comes to a trig function raised to a power, remember we have to apply this 3 steps. So in the end, you see dy over dx will be equal to 3 sine square of x, and then multiply by cos of x. So if I rearrange my term, I will write it as, excuse me, okay, I will write it as 3 times cos of x times sine square of x as the final answer. Okay, so make a comparison. This the final answer for sine to the exponent 3 of x, and this is the final answer for sine to the x to the exponent 3. Okay, so note the difference between the two. Okay, so one is a functions as the argument raised to the exponent 3. Here you raise the entire trigonometric function to the exponent 3. So in this case, what you need to do is you have to apply the function raised to a power, basic rule for derivative. Then you apply the derivative of your trigonometric function. Then you have to apply the derivative of your argument. So there's always 3 steps. If you have a function raised to a power in terms of the trig functions as indicated in this particular functions. All right, okay, so keep those 3 things in mind. So I'm going to move on to another example, and this one is a bit complicated, okay, because you see in here you have cos raised to exponent 3, and your argument now is not just as simple as x. Now you are having the entire function right here. So we call this apply the chain rule. So the same thing here, that I need to apply chain rule. Okay, so power rule, chain rule, also derivative of the argument as well. All right, so what I will do this identify the u, and I will find derivative of u right away. Okay, so I'm going to, u will be equal to square root of 5x plus 2. So that means it will be 5x plus 2 raised to the exponent a half. So du over dx is equal to okay, so I take a half, multiply to the front. Immediately after, I take 1 away from the exponent. So a half minus 1 will be negative half. And what is derivative of what inside this bracket? Is 5. Okay, so in the end, du over dx will be equal to 5 over 2 times 5x plus 2, all of it raised to the exponent a half, or you can write it as 5 over 2 square root of 5x plus 2. Okay, so we are going to use this and apply to our trig functions in a minute. Okay, 5/2 multiplied by square root of 5x plus 2. Okay, so we leave it for now. And because of the chain rule, I'm going to show everyone how to do this step by step. So the first thing you do is you are going to pick up this exponent 3 of this function cos, and then you multiply that with the 3. So you see I will write it as, so let me write it step by step. I will write 3 times 3, okay, and then I immediately take 1 away from that exponent, so that will be 2, but I have to write the exact argument again. Okay, so I write the exact argument again. So this first thing is the power rule. Okay, so I put here the note for everyone, power rule. So the next step is I have to multiply derivative of this cos. Okay, what is the derivative of cos? It's negative sign. So you put negative sign, no more exponent. Okay, it's just the negative sign. And then the argument stay the same, 5x plus 2. So this one I will note for everyone that derivative of cos. Okay, the last thing is time du over dx, which is your derivative of 5/2 5x plus 2. So let me rewrite the 5. So now I'm going to note for everyone, this one is derivative of the argument. Okay, so we break this into 3 parts. So in the end, my final answer for this, if I simplify, it should be, okay, so you see 3 times 3. So I take this 3 times this 3 times this 5 times the negative sign. So I should have negative 45. Okay, down the bottom, I should just have 2 times square root of 5x plus 2. As a numerator, I still have to write sine and this argument, 5x plus 2. And then I multiply this with cos square of the same argument, square root of 5x plus 2. Alright, so this is our final answer. We apply three rules in this case. The power rule, derivative of the trig function, and derivative of the argument. Okay, so let's double check that. Okay, we are good. Alright, so let's move on to the next questions. So the next question, I need to apply the product rule. Okay, so the product rule, because I have sine of a function x squared, and I have cos of 2x, and this 2 is actually multiplied with each other, so I have to apply the product rule. So how do we apply the product rule? The product rule said this. So u times dv over dx plus v times du over dx as the product rule. So I quickly give everyone a reminder here. So then you are going to let u equal to x squared, right? Sine x squared, I'm sorry. So when I mentioned u equal to x squared, because you have a u here as the argument, but since you apply u's as the product rule, we just remember that in our mind, that we have to take derivative of this x squared as well. Okay, so du over dx, derivative of sine is cos. So you are going to write cos, and then you repeat the exact argument, and you multiply by derivative of x squared, in this case, which is 2x. So that is u. So v is equal to cos of 2x. So derivative of v as a function of x will be equal to negative sine of 2x. So derivative of cosine is negative sine. And now I still have to multiply this by derivative of 2x here, which is 2. Okay, so all you have to do now is just put it into these formulas. U, which is sine. Sorry everyone, I just have to zoom it back in. Okay, so I should have U, which is sine of x squared, multiplied by du over dx. So I will multiply by negative sine of 2x times 2. And then I add that with v, which is cos of 2x, and multiply by derivative of u as a function of x. So I should have cos of x squared. I'm sorry. So cos of x squared times 2x. So I'm going to list everything for everyone. So down here, I will write this one as u, this one as derivative of v as a function of x. So this one here is v, and this one here is derivative of u as a function of x. And I just apply the product rule here. So I have u dv over dx and v times du over dx. So in the end, all you have to do is just simplify your answer. And when I simplify my answer, I can see that there's a common factor of 2. So here I will pull out the 2. So I pull out the 2 inside the bracket. I will left with x times cos of x squared times cos of 2x, subtract sine of x squared times sine of 2x. And we just leave our answer like this. We don't need to try to use any trig identity to simplify any further. Alright, so I still have 3 minutes left. I think I can finish the next question here. So we have the trigonometric operation of trigonometric functions. So the same thing apply. In this case, you are going to find derivative of sine. Derivative of sine is cos, so it's just cos. And then you have to repeat the exact argument again. And then the next step is to find the derivative of your argument. So the derivative of your argument in this case is cos of 2x, right? So derivative of cos of 2x. So it will be negative sine of 2x. And then you multiply this by derivative of the argument, which is 2. So right here is just the derivative of sine. Okay, so this here is derivative of the argument, which is cos of 2x. Okay, so keep that in mind so we don't repeat ourselves and doing the wrong step. So the very first thing is, here's your sine. What is the derivative of sine? It's just cos. So you write out the cos and you repeat the exact argument again. But because we have to multiply by derivative of u as a function of x, and what is u equal to in this case? U is equal to cos of 2x. So u is equal to cos of 2x. So to find derivative of cos of 2x, you need to find derivative of cos with a negative sign. So repeat the argument again, but then you multiply by derivative of the argument of 2x, so which is equal to 2. So in the end, my final answer would be, I just rewrite to make it look nicer, negative 2 sine of 2x times cos of 2x. Okay, so don't forget here, this one cos of 2x is the argument of this cos. Alright everyone, thank you.